Hello Earth, welcome to episode 42 of season 2 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time, I recommend you go to github.com/autocolonel/cell to read what this is about. I'm pasting now the link in the description. We're going to continue where we left off. We've been fighting for 10 episodes now. Let's just look at it. What were we doing 10 episodes ago? Yes, I think we're working in. 10 episodes ago we had the conditionals, and it worked in one episode. So basically, if this episode we have a breakthrough, it will be the 10th episode where we're working on the sequences, cell.do, and that's exactly what I want to tackle. The last episode, if I remember correctly, because it was a few days ago, I definitely need to improve the cadence of work. I'm not working enough and not often enough on Cell. We had a really good. We were basically tackling the recursive cell.do, and we figured out a lot of stuff. And also, let's look at the notes of the previous episode. We had an algorithm, a sequence for doing this cell.do when there's no updates. Basically, when the definition never changes. And actually, we wrote two examples, one without an update and one with. Here we update the definition and then we expect to see those changes. I wrote these notes, I think, over the weekend to have this cleaning mechanism to say if you update the definition, and I'm sorry, it's so hard to follow me right now. I have a hard time following myself, so I have to apologize. This is probably just for historical reasons only I'm recording this. This will only make sense in hindsight. Best case scenario. So for every path that has an equal or colon, look ahead to see if there's one with at and this is the cleaning mechanism. This is how do you realize whether something changed or not, because you cannot do a strict comparison of paths because some paths might have references and you want those expanded. So basically you need to clear out the stuff that has equal or colon. This is the mechanism for saying did the definition change or not. And then that also can happen with literals. So we're gonna do that, but first I will just take it step by step, and I want to see if I can already make this definition, this is test work. We don't, it doesn't work, and I want to understand why. So let's inspect what the code is doing. No expansion at all. Why? We're just calling cell put here. Yeah. So good. I would like to debug this stuff by just putting some logs on cell put, I guess. we're setting +1 to all of this. This was before, right? Yeah. Setting +1 equal to int 1. That's just wrong. Oh no, that's correct. That's the definition. So then it's not being called already. I want to see if we're hitting that piece of code there. No, we're not. Why not? Oh yeah, because I'm returning the output. Why? Okay, it's the result. Oh yeah, because it was breaking, I remember. Okay, I did it on purpose. Sorry. We lost a couple minutes on that. Probably 5. Okay. Okay, look at this. We're trying to put 11 to colon sec1 to this. We're actually trying to set the sequence. That is correct. And now we have an issue at line 415. Because it was returning no value, right? The mystery is if I'm returning got current value. Yeah, we got that error for sure. Maybe that doesn't happen there. Yeah, I need to look at when it's breaking. On which path? Okay, so it's looking for this path 11 colon sequence 1 is at. Okay, we already have a result and everything. The question is why is it undefined? Current value here. What's value path? Value path starts with plus. Oh, of course, it's a plus. Okay, that's good. So we have a plus. So what's your problem? Why is it so hard to remember what's the value path? It's where the stuff is, I see. Yeah. Basically here, when I'm implementing the plus, I need to get everything. and delete everything that is at that path, right? Yeah. Let's see if that's correct as well. Target path 11 not sequence at 1 equal. No, I need to take basically all of this, but with the at. Will be value path slice with an at. I think it would be this one, right? No, not value path, target path. No fuera por. Yeah. If I do this, gimme will be get. Yes, that's exactly what I want, right? Oh, wait, I have it in the value path, right? I know, because the value path is lacking stuff, right? Yes. So I'm basically getting the values. Why do I have to do this? Why can I not do this properly? Why do I have to do all this? This is wrong, what I'm doing. If plus was a normal function, you have to access its. Maybe we can implement plus as a normal function. Okay, let's just do something here. We just return 5 always. Okay, we're getting closer now. Yeah, it has to be something silly. I forgot to calling cell get somewhere in this inside do. Yeah. All right, we're starting to get somewhere, I think. Yes. We have this one should be 11, but it's 5 because this is incorrect. The rest looks good, really. Yes. Actually, the rest looks good. Wow. It works. Except that it's 5, right? So let's actually try to yes, also this one. Oh, okay, so 11 we also get the empty, so it's not that only. We need to add the condition that this is the last step. Or dun, 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 step number equals length. Yeah. It worked. Okay, now we need to implement plus. Okay, we need to implement plus. That's good. Nice. Step in definition, step in execution. That's correct. This. Yeah, I want it to be in status of okay in the meantime. It's not correct. Yeah. Okay, so we can try to make it work for replacing, ignoring the sounds. Actually, let's do that because I think we're so close. Bum, 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 bum. Yeah. So we need to do the updates now. This is gonna be a bit tougher. We need a comparing function or a stripper. We can call it a stripper, I guess. So strip colon and equal from a set of paths. Yeah. What was the fancy algorithm I thought over? I just look ahead because the equal or the colon come first because things are sorted. Noise. So iterate the paths, you get a path, iterate any filter the undefined if path index of includes colon, sorry, equal or first equal or what was it, colon, it would be path math minimum of path index of equal path index of colon. No, but that won't work because -1 is gonna screw me up. First colon path index of colon. Is there an elegant way to do this just with 2? Can be -1. Yeah. A loop. If v is equal or v is colon, return k. Yeah. otherwise we look ahead. Dale. I would go stop not path slice path index, so you just look ahead. If look ahead path slice from 0 to k equals this path, actually they should equal stop on true. Look ahead path slice compared to path slice 0k. Actually we can just do it like this, return this, yeah, and then if look ahead, if there's no look ahead, return the path, otherwise you don't return it. So we have the stripper. So now we need to compare the sequence minus the sequence. Sorry, not the sequence, the expansion minus the sequence. So we basically I would do it like this. I could just cheat, although I need better operators for this. What time is it? 10 more minutes. Not bad. The good day is the day that I record something. Like today. Let me switch the music for a sec. What do I want? Yeah, this one never fails. So I like it despite the mess. So if I'm looking at the column, current expansion is yeah, I know what it is. So I would do something like this. Our current message would be you would take the current expansion. So what am I doing? Yeah, the current expansion, and I would just do cell path JS to paths. Oh, paths to JS. What am I doing? Oh, wait, I don't need to do it like this. I can be a bit nicer about it, right? I was gonna use the delete statement. Expansion, current expansion. I need to filter stuff out, right? My current expansion would be, wait, yeah, because it has stuff, right? So if it starts with sequence, it just goes away. Cha-cha-da. It's very easy, actually. I don't know why I was going around it. If path 0 equals sequence, return, no. If it's not sequence, return the path. Shown as the C. No. C. No. Cha-cha-da. So now that we have the beautiful stripper, oh, actually, that didn't sound that good. I didn't even think it through. Well, I think it's okay. So now we have this beautiful stripper function. I can do something like I would take the current message if stripper of current message. How do I go to the definition? I can't. I need to construct what I want it to be, right? But if I strip the message, yeah, because I can just let it expand, right? Pam 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 pakataka. I can let it expand. All the calls can be expanded. And idempotency wins the day. How do I have it? Would be I'm just getting a message. And how do I have the values? They're the message. Let's see. It will be something like Dali go message function path return message name concatenate path like this. But I need to run this through the stripper. Yes, I do. And if these are not equal, look at that. For see, this is why we need a better Lisp, because of this stuff. I mean, I could have put it outside, but you get the gist. This is my goodbye to JavaScript. I'm basically writing an equality with a function that I define myself, and then each of the arguments has a function applied to it, and then the argument to that second argument is an iteration. Sure, I didn't do that on purpose. And this is fine because it has to be different because it goes here. But wait, I cannot just do the put like that. I mean, I guess if the argument changes, all bets are off. What I need to do in that case is just to set only the colon to the whole thing, just to overwrite it, because it's not just good enough to set the new, I also have to remove the old. Yeah, boom. So it just goes away. So now there starts to be a repetition here, and then I might have to do it like I would just concatenate here the message. Yeah, I tried to do that outside, but I'm baffled. I'm at a loss for terms because I honestly forgot which one is the current. What am I talking about? The one that should be or the one that is? My naming is faulty, and any confusion would know that that's the root of all my problems here, or at least a symptom. So let me just be lazy for a change, and we'll probably extract this thing. I know, because I still have to put the V's there. Oh, forget it. It's all in line. Boom. And now for the pièce de résistance, what I need to do here is the same thing for the other one. Just call the stripper on each. Sorry, I need the stripper here only. If stripper set step in execution is different from stripper step in definition, I just did here, right? Yeah. I need to annotate this code stat. Oops, 494. Oh yeah, it's path index. Hello. Well, it's going on forever. I wonder where does it go circular on me? Do we see this? No, it's at the path level, right? Yes, because it has to be the G equality. What were you thinking? Go to self. We should by default have a good equality thing that does paths too. There, yeah. Oh, if they're not the same, wow, I'm really... It worked! It worked! Okay, that's really nice. So now let's turn this off. I'm gonna stop here. This is a good moment to stop. But what we have is a recursive definition of cell.do that changes, that updates things. It's unreadable. I need to annotate the source code, understand what I'm doing, and I need to solve the problem of plus, how I'm going to implement that elegantly. But we have a recursive definition of cell.do that I think is going to do the trick. I am very happy. It took 10 episodes, but it's starting to work. Thank you for watching. I'll see you next time.